acceleration. Now, when we think about the motion of the body, then no doubt we discussed the concept of velocity. Okay. Now, when the body is moving or the object is moving at that time, it is not necessary its velocity is always constant. During the motion, velocity may change. It can increase, it can decrease. So now here we have to introduce one more physical quantity with the help of which we can understand about the change in velocities. So that physical quantity is acceleration. Now acceleration is defined as change in velocity per unit time, that is called acceleration. Or we can say rate of change of velocity, that is called acceleration. Now, suppose at time t1 instantaneous velocity is v1, at time t2 instantaneous velocity is v2. So average acceleration, that is defined as change in velocity upon time interval. So average acceleration a bar, that is change in velocity, that is final velocity minus initial velocity, that is v2 minus v1, upon time interval, that is t2 minus t1. So we can write that is delta v by delta t. Its unit will be meter per second square. And from this one, we can write its dimensional formula m0 L1 t minus 2. Now, the concept of instantaneous, that is the same as we discussed in the previous theory. Instantaneous acceleration. So now we have to calculate this ratio delta v by delta t for infinitesimal small time interval. And that is instantaneous acceleration a equal to limit delta t tends to 0 delta v by delta t. So we can write acceleration a, that is dv by dt, and this differentiation, that is also represented by the symbol of dot over the symbol of physical quantity. So differentiation of v dv by dt, that is also represented as v dot. Now actually v, that is dx by dt, so we can rewrite acceleration, that is d by dt of v, that is d by dt of dx by dt. Okay, so we can write resultantly this one as d2x by dt2. It implies that acceleration is the double differentiation of displacement. Double differentiation of displacement. Clear to all of you? Any doubt? Okay. Now see, again from the graph one can easily get idea about the acceleration. Say first we think about the graphs of positions versus time. Suppose this first graph of position versus time, that is curved moving upward. Okay, now we already discussed this thing for position time graph. If the graph is curved one, then at any point, means at any instant, if we want to calculate the velocity, then we have to draw a tangent at a point on the graph at that particular instant. And then if we find out the slope of that particular tangent, then it will give you instantaneous velocity. That we already discussed. Now we will use that thing here. Suppose at a time t1, here the point on the graph, that is this one. So at T1, if we want to find the velocity, then at this point we have to draw a tangent. Then the slope of this tangent will give you instantaneous velocity. Then after at time T2, the point on the graph is this one. Again draw the tangent as shown in the figure and find out the slope. So slope of this upper line, which one is more steep than this first one? So slope of this line at instant T2, that will be greater than of this tangent at time T1. It implies that this final velocity is greater than initial velocity. So V2 minus V1 will be positive. So we can say now the acceleration for this type of motion, which one is represented by position time graph here as shown in the figure, is positive acceleration. Clear? Or we can say the particle is moving with positive acceleration. Okay. Then after, if position time graph, that is this type of curve as shown in the figure, then at different instant, if we take the tangents at a different point on the graph, and then if we find out the slopes of it, and then we can observe this thing, the slope of this line, that will be less than slope of this one. So final velocity is less than initial one. So acceleration will be negative one. Acceleration negative means the velocity is decreasing one. And acceleration positive means velocity is increasing one. Then after, if the graph of position versus time, that is a straight line graph inclined with time axis, means the velocity is constant because slope of this line is constant. And if velocity is constant, means change in velocity, that will be equal to 0. So acceleration will be 0. Now, with the help of velocity versus time graph also, we can get perfect idea about the acceleration. Suppose velocity time graph, that is as shown in this first figure, okay, that is a straight line graph, okay. Now here we have to consider the cases in which the acceleration is constant one. So if we take the velocity time graph, and then if we find out the slope of it, slope of graph, that is delta V by delta T, then that particular slope will give you acceleration. And here we have to consider the cases of constant acceleration. So we will think about velocity time graphs, which are straight line graphs. So first one, that is the straight line moving upward. So slope of this graph will be positive. So we can say the motion of the particle is in positive direction with positive acceleration, because this graph is in first quadrant, it is in positive direction. So motion is in positive direction with positive acceleration. Then this second graph, line is moving downward. So slope will be negative. Clear? So if slope is negative, means acceleration is negative, means velocity is continuously decreasing one. But the graph is positive side. It implies that motion is in positive direction, but it is with negative acceleration. Then after, third graph, the graph is on negative side, and now here it is increasing in negative direction. So we can say motion is in negative direction, that is with negative acceleration, because final velocity is more negative compared to initial one. And negative velocity means it is moving in negative direction. Okay. Then after this fourth graph, here in this fourth graph we can observe at time t equal to 0 the velocity is maximum, then that velocity is continuously decreasing one. Then at a particular instant it becomes 0, and then after the direction is changed. This is positive direction, this is now negative direction, and then velocity is increasing. So here this type of graph, that is for the motion of the object which one is thrown vertically upward like this. So when you throw it vertically upward, initial velocity is maximum. As it moves in upward direction, its velocity is continuously decreasing. When it reaches at the maximum height after some time, its velocity momentarily becomes 0. Then after, it moves in downward direction. And now its velocity is continuously increasing one. But the direction is now changed. So this is the graph for that type of motion. Clear to all of you? Now one more important result from the velocity time graph. Suppose our velocity time graph, that is the straight line graph parallel to time axis. It implies that the object is moving with constant velocity. Now, suppose for this particular graph, if we find out the area under the graph, then area under the graph, that is this side, that is u, into this side, that is time t. But u, that is the velocity, t, that is time. Velocity into time will give you displacement. It implies that if we have velocity time graph, and then if we find out the area under the graph with respect to time axis, then that will give you displacement. Clear? Now,